there's a word inside, full of hate, full of pain, where my demons hide. Without shame, without a trace, and I can see their eyes looking at me like I'm a slave. They say to fall in line, but I won't follow the way. Breaking my heart or taming the flames, chasing the sun or waiting for rain. And I'm bouncy, saw the walls I made. I can run, fly high, but I will not escape. I'm different, they're taking on it, choking me. The enemy, the black one and I heard a sheep. Because I know, I'll steam all like the glow. The last to fall, I'm the last to fall. My mind is a labyrinth, something hard to figure out. Take a look just inside of me. Never be what they want me to become, no. Welcome to the reckoning, our war is coming, it's a showdown. Even if you're made to break me, I will never, can never bow down. It's written my DNA, am I lost, am I insane? Maybe then it's someone to blame, to feel less inhumane. It's just a virus that should be erased, throwing me down till I asphyxiate. Staring to the void of a world that I cannot hold. Maybe I'm getting paranoid, but I'm sure of what I know. A place where hate is gonna rise, and love is gonna burn. Where stupid men are shot the stars, just to get a fucking crown. Welcome to the reckoning, our war is coming, it's a showdown. The stars will rise again, from the absence of light we are facing. See I come to the tide by the sweat on my shoulders. It's even heavier than before, more than you could ever know. But even if you're breaking me, I will never, can never bow down. Why so anxious? Take this medicine. Will I feel it right or be pushed to the edge? All this darkness taking over me. Beneath the surface, holding my last breath. They're breaking down everything I am. Saying I'm crazy, but that can't really deal. I'm gonna face the darkness till the pain pursuing it. Rising from the ashes of something that's never been. Welcome to the awakening. Welcome to the reckoning, our war is coming. I fight until the end, until the pain comes to an end. Watch me come alive, I'm here to tell the tide. Even if I'm broken, I've never bowed down.
Always knew a missing piece, waiting in the dark, like a quiet melody. And if I listened hard, I could hear the sound rising from the ground. Every moment until now, I was dying to change from a spark to a flame. I want fire, burns bright, fighting to reach it. I'm flying, falling to pieces aside. Even when it's hard, even when it's hard, never gonna quit, never gonna stop. Tonight, lighting up the black sky.
Yo, we're live again. Welcome. Okay, so today we're gonna check out some SIMD programming in Rust. So I found this crate called MemCHR, which is written by Burnt Sushi, the author of RipGrip. So it helps you to write generic SIMD programming in Rust. So let's check it out today. So first of all, what what the hell is SIMD? You know, let's see what is SIMD. SIMD is basically single instruction, multiple data. So what does it mean? So let me just like draw a rough sketch. So here you have your CPU. Okay. Okay. Have your CPU here, and we go for you have bunch of registers here. So okay, let me just draw one square here, one square here. Okay. So this is your CPU, this is your registers. Let's consider these as processing units. PE. Excuse my drawing. Ah man, okay, that looks horrible. Let me just draw it later. Okay, so we're gonna connect this. Okay, so we have multiple data lanes. Okay, excuse my drawing, but yeah, so the idea is here you have your CPU, you have your processing unit, let's call PU, you have your registers. So the idea of SIMD is basically your CPU has a processing unit. So let's say I have a string called be hello world. Okay, and now I need to check if this string has a letter H. So how do you do that? So usually the way your CPU does it, like a CPU accepts only one instruction per at a amount of time. So basically you can only send one instruction to your CPU. So that means you can only compare one of these bits with the byte H. So with the byte H. So let's say if I just go here, I just compare H with this H. We do like, I mean, if you know the bitwise operations, if you write an equal, it's basically an XOR. So you just do an XOR of this with this, 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 and see if any of these are 1. So if it's equal, your XOR will be 1. Yeah, so yeah, that's the basic, like how you do it in a scalar operation. But if you have to do it in a vector operation, you store these you store these bits in your register. Your CPU, you get a instruction in your CPU. Your CPU will have a instruction unit. Your instruction unit will send your CPU, and it will send it to your processing unit, and processing unit has multiple data lanes to your registers. And the idea is you compare all of these bits parallelly. You do a XOR operation on all of these bits parallelly. So that's the basic idea. Usually, for example, my Mac CPU, it has a 128-bit register, that is 16 bytes registers. So at one point of time, you can compare, you can do 16 bytes of operation parallelly. So that's the basic idea of SIMD programming. Usually your compiler does it for you. You don't have to write a SIMD instruction by hand. I mean, that's like a usual case, but as smart as a compiler is, it can't predict what you're trying to do every time. So that's why we have all these SIMD crates. So one of those crates that is like a prominent is in Rust. It's called memchr. It's written by Burnt Sushi, the author of RipGrip. So I do think he's using this in RipGrip as well. So let's actually try it out. So let's go to the documentation. So this provides a high level access to your SIMD instructions, basically. So Rust also has something called core SIMD. But this requires nightly. I'm waiting for it to become stable actually. Until then, we're gonna use memchr. Looks pretty good. So let's do one thing. Let's just create a bin. Let's just create this test. Let's just add cargo add memchr. Yo, what's up? Okay, so we add memchr. We're gonna just copy this example. Okay, let's just copy this example. Let's just print. Okay, so you have your haystack. What was the? Okay, so let's just see what is it. So let's just run it. Okay, return 10 as you had in the answer. So what is it exactly doing? So this is calling this function memchr. What is this function memchr even doing? Okay, so let's just read the command. So it just searched for the first occurrence of the byte in a slice using SIMD instruction. So this internally calls search slice with raw. Search slice using a function that operates on raw pointers. Okay. So this gets the point of your haystack pointer, like the starting address. You do a pointer add here on this, so that will give you the ending address of this haystack. So this then it calls this find raw function. What is this find raw function? So this find raw function is memchr raw, which has multiple CFGs based on your architecture. So one thing I didn't tell you is there are like multiple SIMD instructions. So one is called AVX2. So AVX2 is for mostly Intel processors. So it was made by Intel for SIMD instructions. So if you are using a SIMD CPU, Intel CPU, you would be using the AVX2 instructions. If you are using a Mac, you would probably be using Neon instructions. So that's what this is like generically calling here, based on your CPU arch. So we'd be concerned about this. So let's go here. Where is this, Steve? Let's expand this. Okay. Okay, so if Neon is not enabled in the while actually compiling, then it would panic. Otherwise, it would do this one new find raw. Let's just see what this one is. I have memchr compiled. Clone, sorry. So I'm gonna go here and search for one. Struct one. So we'll be concerned about Neo. Okay. So it was calling this function exactly. Okay, we check if Neo is available level. But what do we check it with? Okay. So go here. The S1 is a needle, V1 is plat. What is plat? Create a vector with 8-bit lanes with a given byte repeated into each lane. So let's see what actually splat is. Okay, so basically you actually broadcast all your data into the register size. So I believe this is what it does. So let's say you have your hello world here, but your register can only hold, let's say you have a very big string like this, but your register can only hold 16 bytes of data. So this would sort of broadcast 16 byte at once. I believe so, I guess. Is that what it is? Oh no, okay. So you have your needle here. Splat would basically broadcast your needle into different data lanes. If you have 16 data lanes, it would broadcast into 16 data lanes. So it can do things parallelly at once. Okay, that makes sense. Yeah, we were talking about needle here. So yeah, okay. So okay, so you would do here find raw. Return a pointer to the first occurrence of needle with given age tag. If no occurrence exists, none is returned. Okay. Yeah, that makes sense. Stack has length must be at least what? That depends on your CPU architecture. So yeah, that makes sense. So I mean, this would depend on your registers. Yeah. So let's just see what it actually uh, cargo build emit ASM, I believe, is what. What was that? Yeah. So if you have it in your have my target here. So what I'm gonna do is .c emit asm .c emit asm .c emit asm of what was that option? Rasi emit asm, yeah. Emit asm. Man, what's wrong with me? Uh, it's been a while since I used C. God damn it. Can we even do this? Forget about that. I'll just go to the target tabs. I think you would now have yeah, this is what we want. This is pretty big. Okay, so we would wanna progress. I believe it's called MDR, LDR. LDR. Okay, so God, that's crazy. Okay. I think this is loading 8 bytes into this register. this is, I don't think this is actually helping, but let's just see. Okay, so there is something called memchr2. So if I have to search for something like P, I would use that. So this would basically what it would do is, I mean, so this is your haystack. Haystack is some foo bar bass. Let's say this for example. So you are you want to search for both Z and B. Now your SIMD instruction will load this in like 128 bits of this in the register, and start running the Z this. I mean, don't mistake here. When you have like two needles, it still has to do these two in a scalar manner, like iterative manner. It won't do it parallelly. But this search here in this would happen parallelly. That is the basic difference in SIMD and parallel programming. Yeah. So when you do this, you would get what? You get 4. Okay, 4. 1, 2, 3, 4. Okay, so this memchr2 basically returns the position of any of these needle which were found first. So it's basically doing this. I mean, same as doing that. So let's just see what is it doing in here. So you would have to go to memchr to neon to see, you can see, so this is basically iterating over the two bytes. Whichever is found first is returned first. So here if we go back here, so here you have your haystack and this your needle, and let's say if we have 2 bytes here, we have, let's say, E. So this gets executed first parallelly in a SIMD. So H is sent in the broadcasted in the data lanes through something called splat, and you have your E. So H happens first and E happens after this. So this is still iterative, but the individual instructions are parallel. That's the basic idea. And here also you can see you just have memchr until memchr3. I'll show you one minute. Memchr test test See, you can see we just have till MCHR3, because if we have if you have like more and more needles, it's literally same as doing the things iteratively. I mean, it would actually be pretty slower than that. So that's why it's not a good idea to have a needle more than three, or like more than one if that matters. Like, so yeah, like there are like a couple of articles where you can see that like adding the SIMD instruction had actually the slowed things down. Yeah. So let's do one thing now. We have our compiler here. We have our lecture, and we for sure are not using any SIMD here. Our compiler might actually be using SIMD here, but we don't care. We want to try it out, right? So let's just add memchr here. So there you go. So where can we use this? So this is one of the examples. See, so here instead of doing this, we can probably use memchr of C is sound. Let's just add this here. I mean, this is a character. If we're checking 1 byte, I don't think this would actually matter that much. Where can we use this? Is this alphanumeric? So what is this alphanumeric term? So this is one of the examples where we can actually use SIMD. But is it doing SIMD internally? That's what I'm checking right now. I don't think so. Okay. I just have a feeling it's gonna slow things down. I think here we don't have to use SIMD. We can use some kind of table. Let's just Can we do contains there? Okay, so we can just start using something like that would be kind of crazy. Yeah, actually, yeah, that is MCHR. So our haystack is basically in bytes, and needle is something like uh, 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 that is so it's the same as doing this as bytes. Byte, what? We convert this into byte. We get byte out of it. Actually, for what, man? I think there is an implicit conversion. You know what? Let's just create a new. Actually, so here, let's just have a file of U8. U8. Replace all characteristics with Wait. MCHR, the needle is C, A stack is like so okay. That's about it, right? That makes sense. Yeah, we don't need MCHR honestly, but I think it's better to do bytes.rs, I guess, where you have your stuff bytes. Okay, so let's just write this bytes. This has a lifetime of p. Let's say stores bytes internally. So here you have bytes. The function, that's fine. Let's add SIMD is fine. Let's add multiple functions. So let's add is punctuation. Function is white space. It's not true. We are doing SIMD. So let's just add is CHR. What the hell, man? CHR. We need a what is it? Status. Basically. What's some other function that we need? Is alphanumeric. Let's just copy this alpha. Rick. What does it look like? Okay, this will be quite difficult. What? Did the stream just crash?